All right, N1-4. So today we're starting series, and a series is just a sequence, but with everything added up. See these? So you're just adding all the terms, and so now it's a series instead of a sequence. And there's this fancy-looking sigma, that's what it's called, and it just means add up all the terms from 1, this is your starting number, for n, or I in this case, or k, or whatever they, like a bunch of these they use k, but k is really meaning the kth term. So typically I will use n for nth term. It doesn't matter what variable you use. It just says to add up all your sequence, after you plug in 1, then you plug in 2, then you plug in 3, all the way up to this number up here. And they use I and n or k and n, but it doesn't matter the variable. So if you have this formula, you're just going to plug in 1. So if I plug in 1 right here, 3 times 1 plus 1, what is that? 4. And then what if I plug in 2? 7. And then I plug in 3. And once you get so far, you should see what it's increasing by. What's it increasing by? So just go all the way up to the 10th term. So this is the first term, second term, third. Oh, that should be 10. Should this be 9 or 10? Well, what's 9 plus 1? Don't say you have no idea. You're scaring me. Scared. Is that right now? Because if you wanted to, you could keep going, but once you figure out what the sequence is, you don't need to keep doing this, right? Because you'd have to go all the way up to 10, and that would be kind of burdensome. So where do we stop at? What's the 10th term? 31? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we stopped at 10 because of right here. You stop at the top number. So then you just take your calculator and add all those up. What do you get?
Add all that together.
Yep. So you just add them all up. What do you get? 175. That's more than 100. All right, then you do the next one, and we're going to start at what number are we going to plug in first? And then when do we stop? So we're just going to plug in 3, we're going to plug in 4, and we're going to plug in 5. So you get 10 plus 17 plus 26. 3, 4, 5. You start at 3, and you end at 5. Do you get it? It looks confusing because of that fancy little E thing, but don't let that scare you because it's actually pretty easy. You just start at this number, end at this number, plug them in. And no, never. You smash your finger in a log splitter? Is it one of those log splitters that go on the back of a tractor or something? What kind of? Oh, we used to have a log splitter one on the back of a tractor. What's your log splitter look like? Is it like its own machine? Oh, okay. Cool. I think ours was just that, you know, what's it, hydraulic or whatever, where it's run by. But it's not on the back of a tractor? Oh, it is on the back of it? Oh, okay. And you smash your finger? And it pushes, yeah, it pushes the log in. All right. Did you already do number 2? You guys got number 2? What's number 2? What's my numbers I'm adding up? What's the next number? Then the next number. What's it increasing by? And we do all the way to 6. Is that 6? Just smash the finger in a log splitter. What do you get? 90? Oh, no, then add them up. We're doing it. This one's the same thing. I just didn't write out the work.
Oh, no.
Yeah, we just went ahead and found the indicated sum. Good question. Yeah. I see why he's asking that. Say it again. Say it again. No, you really didn't have to find the sum, but we went ahead and did it. Good question. All right, next page. Now you need to go the other way. Now I give you the series, and you need to find the summation is what it's called. That little E, look up here. The little E, fancy Greek E, which is called sigma. That's summation. Summation or sigma notation. So if I say write it in sigma notation, that's that little fancy little E. So you write your fancy little E. And what's going to be our, first I would, too much talking. Okay, so the first thing I would do is figure out what is our formula. Is it just 5n? So if n is 1, 2, 3, etc. So what does this one have to be? What? Good. So we're going from n equals 1. You can use k if you want to stay consistent with the front of the notes. I just use n. Doesn't matter. N equals 1 to what? When does it stop? 50. And that's it. So try the next one. Yep, that's it.
All right, this one's a little more complicated.
Can we start at n equals 3? And if I start at n equals 3, where would I end? 15. And then what's my formula? Good. You can do what? N minus 2 or something? Or n plus 2? Yeah. You could do n plus 2 and go 1 to 13. That's okay. Nope. Doesn't matter. Okay, the next one. Write your fancy little E. I'm hanging. N equals 1, and then to how many? 4? And then what's my formula?
1 over 3 over 9.
Good. Yep. Okay, now you might have to glimpse back at one, or I think it was the last previous notes. There was these things with negative 1 to the n and negative 1 to the n plus 1. Which one is going to make the even terms the even terms negative? See how this is the first term, second term, third term, fourth term? So it's either negative 1 to the n. So if I take negative 1 to an odd power or an even power, will it be negative? Odd. So if your odd numbers are negative, if your odd terms, I should say, are negative, you're going to multiply your formula times this. If your even numbers, are you listening? If your even numbers are negative, it must be this one. Let's try it. So for example, if I do My formula is not going to change. N equals 1 to 4. I'm just going to multiply by this or this. So we're going to try the negative 1 to the n plus 1. So if I take negative, if I put a 1 in here, and I'm going to times it by 3 over 10 to the n. So if I put 1 in here, does this end up being even? I mean positive, sorry. Does that end up being positive? So negative 1 to the 1 plus 1 would be negative 1 squared. What's negative 1 squared? Positive or negative? Positive. So our first one is positive. If our odd ones are positive and our even ones are negative, then you have to use this one. And I think it says right down below. Doesn't it say at the bottom of your page? What? It's on the bottom of the page. So this is if your even ones are negative. Are my even terms negative? Look, 2 is even.
Oh, yeah, you're right.
Got it. If my even ones are negative, use this one. And if your odd ones are negative, use this one.
So how do you apply that to that?
You just times it by whatever your formula would be. You just include that in your formula. That way it makes it alternate even odd. So all of you need to answer E. Answer E. What will E be? It'll be the same except for what's going to be different. And if you're lost, first, pay attention. Secondly, read this right here. If you didn't read this, read it. This is if it alternates negative, positive, negative, positive. If your odd numbered terms are negative, use this one. If your even numbered terms are negative, use this one. So somebody give me the answer to the last one. Good, and we're still going from 1 to 4. Any questions about those two? All right, turn the page, one more page, and then we'll do the quiz. So we're going to start this because pretty much this is just a formula. You're just using a formula. So we could write a summation.
Wow.
We're just doing this first page. So, listen, we could write a summation going from, I'll write it over here, n equals 1 to 90. And then I could come up with a formula. What would be my formula? You're close. What would be my formula? What is it? 2n minus 1? Or 2n plus 1? Okay. So my formula is 2n minus 1. Now I could plug in all the numbers from 1 to 90 and add them all up. How long is that going to take me? A while. So they know. So somebody somewhere. And don't worry, if you go to the very last page, I think of this packet, all the formulas are on one page. Yeah, all right. On the quiz, you get your formula. Those 2 formulas you get today. That's because I don't like tricks, because you're not really thinking. You're just using a trick.
You'd rather go through pain than bring it back first.
No, I want you to learn. All right, so all you do is plug in we're not going to use this, really. We're going to use this. Because we don't want to have to sit there and plug in all the numbers from 1 to 90. So we have S90 is 90 over 2. I'm just using the formula. A1 is 1. And then what's AN? Well, you use A90 equals your other formula, which is what? AN equals A1. Hold on. A1, I can't write. That would be helpful. A1 plus D to the N minus 1. Remember this formula? So to find A90, you just write A1. What's our D? What's our common difference? Times 90 minus 1. So that'll give you your A90. What will it be? D is your common difference, what it's increasing by. 179. That's what goes in here for AN. Now to get, that's your 90th term. Now what if we want to add up all the numbers up to the 90th term? Nope. So now you just plug everything in here, which is this, and just put that in your calculator, and what do you get? 180 times 45? 8100. So all you're really doing is using that formula up there at the top. You just might have to find your AN. Uh-huh. Uh-huh. Got it? Okay, so now you're going to find the sum to the 60th term. Sum up to the 60th term, so we're finding S60. So you go 60 over 2 times A1. What's A1 going to be? How do we find A1? Just plug in 1 right here. So 4 times 1 plus 1, and that's 5. And then how can we find the 60th term? So I think that's what Travis was saying. Can I just plug in 90 right there? Yeah, you can do that. If you can see the formula and you know how to just come up with the formula and plug it in, that's fine too. A lot of people have a hard time getting that part. All right, so now what is it, 241? Now just plug this in. What's our sum? $246 times 30. So you're just using a formula to find your sum instead of just a log guess. Okay, now a story problem. What if we have logs are stacked in a pile? How many logs are in the first thing? Okay, circles. How many circles are in the first row? There's 15 in the first one. There's 16 in the second one. So obviously, what's our D, our common difference?
-1.
Our common difference is 1. Our A1 is 15. And they want to know the bottom row, it goes all the way to 51. How many terms are there? So we're trying to find S, what number? How many rows are there going to be of circles? No, because it starts at 15. Is it 36 rows? 37 rows. Because if you say that again? 15 plus N? Uh-huh. Good. Why is it 14 plus N? Right. You got it. So there's 37 rows, because if you do 51 minus 15, you get 36. But you have to remember that's not counting. That's counting, like, how many jumps, really, instead of how many rows. Does that make sense? It's counting jumps, not rows. So you have to remember to add in the first row, which would be 36 plus one more row is 37. The other way you can do it is just use your formula. And our formula, remember, is AN equals A1 plus D times N minus 1. So you can just use the formula and write 51 equals 15 plus 1 times N minus 1 and solve it, and you'll get 37. So you can just use thinking to do it, or you can use the formula. Doesn't matter. Right? This was just kind of using mathematical reasoning. If we solve this equation, you'll get N equals 37. So we're trying to find S37. So plug it in the formula. So now you got to find the sum. It says how many logs, yeah. Now you got to find the sum because you're adding up all of the rows. Now you can add up all the rows, 15 plus 16 plus 17 plus 18 all the way up to 51, or you can use the formula given at the top of the page, which is 37 over 2 times A1, 15 plus 51. 1,221. All right, so and that was all for, notice up at the top, this formula is for arithmetic. These are arithmetic series, not geometric. Tomorrow we'll do geometric.